One of the most popular, if not the most popular, architecture in machine learning is the transformer, and one of its core ideas is attention. So I decided to release a series of videos that I'll split into different concepts where I want to teach you all about transformers and the attention part of it. In this one, we'll go over the intuition and how you can think about attention in transformers in a more correct way than what is usually taught. And I think that the problem starts with the word attention itself. And this is because one word is ironically very difficult to describe the concept. When we think about attention, and if you pause for a second and if you try to do this, we're constrained to what that means for us. So if you ask yourself, what does attention mean to me? It usually is something that fits in sentences like I'm paying attention or I wasn't able to focus my attention. This leads us to think that attention is a zero or one thing, or rather a scale where we can pay more attention to something and less attention to something else. But before we continue with this video, I want to invite you to join the Tech with Tourist Inner Circle, a private group for programmers that want to grow their skills and explore new and interesting topics within programming. When you join, you'll get access to weekly group calls for members only, where we'll do everything from teaching classes, have open-ended discussions, and explore new and fun projects. When you join, you'll also get access to a private Discord server where you'll be able to chat with other members and with me. And last but not least, you'll have access to exclusive pre-recorded courses on a range of different topics such as front-end development, back-end development, machine learning, tooling, and much more. To join, go to techwithtourist.com/IC. That's techwithtourist.com/IC. And because of this, we're limited by what attention means within the context of a transformer if we try to translate it one to one and try to interpret it in a way that we think about attention instead of trying to understand the internals of the architecture. It is very common to see this explanation where we say that the model is paying X% attention to one word and Y% attention to another word. So if we have a sentence like the cat jumped over the furniture, you usually see a graph like this either horizontally or vertically, where we split the sentence into different words and we assign a attention percentage or intensity to a particular word. And since cat is assumed to be the most important thing, we assign a 60% attention importance or weight. And then we say that words like D or even D here at the beginning don't matter as much. But this is an incorrect way to look at it because we end up translating what we think of as attention one-to-one to something that doesn't work like a human does. So if we try to look at this explanation, we're going to see that first of all, the model is not going to assign an attention score to each word individually in a flat way. It's not like the model is looking from the outside at the tokens from the sentence and saying, I think that cat is very important and I think that over is less important. And the second mistake with this explanation is that the model itself is simply not choosing what to pay more attention or less attention to. The model is not ignoring certain things and paying attention to some things. Even if we would consider that to be a scale, the model is simply not doing that. It is a much more accurate intuition instead to say that the model is conceptually updating each word's meaning based on the words that came before it or after as well, depending on the architecture. Since there are architectures that don't retroactively update the meaning of words and there are others that do so. It is also a much more accurate intuition to say that the model is not choosing which words to pay attention to or which word to ignore. And here I think is one of the key lessons necessary to truly understand transformers and the attention architecture. We need to decouple ourselves or detach ourselves from this idea that the word attention means what the model is doing is the same thing that we do as humans. It is simply a word to try to describe an architecture, but it is not a one-to-one translation from what we do as humans to a model. Instead, we can say that the model is computing which other words change the meaning of a word and in which direction. This is also one of the reasons that I say the model is not looking at a sentence in a flat way. The model is not saying the word cat is more important than the other word. The model is pulling meaning, or in this case, updating the meaning of the word cat based on all of the words that came before it, and it is basically essentially changing the meaning of that word and in a particular direction with a particular strength based on the weights of the model. And I think a much more visual representation would be something like this. So if the sentence was again, the cat jumped over the furniture, we start with the word the, and since this is the first word, we don't have any context to pull from the previous word, so we can think of this as the initial state. And then we have the word cat, and here the word cat is going to look at the previous words, in this case the word the, and it's going to alter the direction of the meaning and also decide how much. And that's why I said that the correct intuition is to think about the direction and the strength of the direction instead of how much attention the model is paying to each word, because here the cat, both of these words are important for the context of us understanding what this sentence is actually saying. If the sentence was something like, I'm inside of my terminal and I ran cat, then the word cat would have a completely different meaning because the model would be able to look at the past tokens and see, for example, the word terminal. That doesn't mean that the word cat or terminal are more important than the other. It simply means that the word terminal is going to alter the meaning of the word cat in a particular direction with a particular strength, which allows the model to contextualize that word and know what the meaning is based on the context around it. Then, if we look at the word jump, here again, this word is going to pull context from cat and from the and update the meaning based on those past tokens. If instead the sentence was something like, I was outside and I was jumped, meaning someone tried to rob me or hurt me, in that situation, the word jump would have a completely different meaning, and we cannot look at this sentence, the cat jumped, and say that cat is more important than jump or the other way around. And this ties again into the point that the model is not paying more attention to one word than the other. It is simply deciding, okay, this word, I'm going to pull from the previous word that I see here a certain amount of meaning that I can extract from that other word, and this is going to allow me to essentially push this word that I'm working with, quote unquote, right now, and send it in a new direction. You can think of it like that. And then we have the rest of the words over the furniture, and the same thing happens here. And like I said, there are some architectures that update the meaning of past words, and there are other architectures that simply look at those past words as context to be able to inform the meaning of the current word. One of those is bidirectional, and the other is a decoder only architecture. And to conclude this video, I think that most importantly, we should forget about words and sentences and instead just think about the mechanism of what the architecture is doing under the hood. That's because transformers and the attention mechanism are currently used in a variety of other subfields besides just text generation. It is true that text generation, or rather I should say text translation, was what they were created for, but since then we found a lot of different use cases for transformers and for attention mechanisms. So if we try to detach again ourselves from this idea that transformers means text completion or predicting the next token, and instead we try to focus on what the model is actually doing under the hood, then it becomes much more easy to understand this. The fact that we can look around context within a particular sentence means that we can also do the exact same thing for a image. We can also do the same thing for a 2D maze and a bunch of other use cases. And I think it's important to look at it this way because I suspect that this prevents a lot of us from truly understanding them, since we're stuck on this paradigm of words and sentences instead of again looking at the internals of the model, what's happening, and not always think about it from the concepts we hold about attention, which are very limited and flawed. With all of this being said, in the next video, I'm going to show you the most simple and intuitive way to implement an attention mechanism using NumPy in a way that will allow us to print everything along the way and see exactly what's happening. And I think this will help you even further understand what attention truly is about when it comes to the mechanics and help solidify your understanding of it. I hope this video was helpful to you, and I'll see you on the next one.